Hello, my name is Alex Cork and I work for ECS Power and Control Limited. We undertook the BMS installation here at Beal High School. We're in the plant room at the moment. This is the main control panel. There's a number of these dotted around the school. This is like I say, the main one. Within this compartment there's some low voltage BMS controllers. This is the BMS controller interface. It's more intended for use by engineers, although users can enter a basic mode and view various statuses and set points of the system. Within this section we've got all the mains equipment and the power and switch gear. It's door interlocked, so you cannot enter this compartment with everything on. This section isn't door interlocked, allowing our engineers to get inside with everything energized, but like I said, it's low voltage, so there's a reduced risk of electric shock. So those white lights indicate that the control circuit is on, live and healthy. They will only go out in a serious failure, power cuts, or if a fire alarm has gone off. There's a knock-off button by the door which will shut all of this down. There's some fire detection equipment in here above the boilers. If flames are detected, this will switch off. So there's a fairly major problem if they're off. The gas valve, which is providing gas to the 4 boilers and the CHP, has got a limit switch on it, so it will tell you when it's open. There's also indication on here telling you that the gas valve is open, so if the boilers go off for any reason, the CHP goes into a fault and you come in here and the gas valve isn't open, you know that again you've got a fairly serious problem.
We're now in the tank room, which is situated to the left-hand side of the plant room. I'll start going through some of the valves. Basically, we have the main incoming gas valve, which to isolate is just a pull and push down to close. We then have 4 sets of heating pipes. 2 do block A, 2 do block B. We then go through to the cold water mains. This is the outgoing from the tank through to the blocks A, B, C and D. This is the main incoming water main from the road. Again, to shut it off, they both just pull the levers down and down. We'll then go through to the cold water booster set, which is twin pumps that run about 3 bar. This keeps the cold water and the hot water pressure equal throughout the whole building. Again, to isolate it, there's a valve here, which is the outlet. The valve above is the incoming water mains, which again you can isolate from there. These pipes then run round the wall and through down to the plant room next door. We're now in the main plant room. Basically this was the existing plant room, and what we've done is we've altered the pipework to form what's called a low loss header, which is this big long pipe here. And basically we have all the returns for the building on one end and all the flows for the building come back in on the other end and mix in the middle. So we have, I'll go through the valves. We have the first valve on it is the hot water return. These are all labelled up on the chart, numbered and labelled on the charts. The second one is the kitchen return. The next one along is block D return. And then we go to block A return and block B return. It's the same principle on the flow. It goes kitchen, block A, block B, block D. Pumps that we've installed. This is the main pumps which feed the new block D and also the underfloor heating systems in the hub. We then go back through, we have the 2 pumps at the top serve the kitchens. The 2 pumps below it serve block B. We then have 2 pumps here which do the hot water. This is the hot water to the 2 new cylinders. We then have the next set of pumps down which serves block A and also the hairdressers, which they call block C. Maintenance wise, the only bits of maintenance in the plant room we have are the heating strainers, which are these two items here, one for block A system, one for block B system.
So this is the main navigation menu system. You've got your air handling plant in the roof plant rooms at the top, the interface to the Mitsubishi system showing all the fan coil units. We've got another panel down in the tank room with some ancillary monitoring, and then we've got the traffic light alarm system showing reds and greens for healthy and fault. Same kind of thing for the Mitsubishi system, and then some electrical metering information. So I'll go through from the top. So north plant room, we've got air handling unit number 1 and associated toilet extract and domestic hot water. So if we start with the air handling unit.
Which is north?
That way.
So it's to our right.
Yeah.
Okay.
So the air handling units are all fairly similar. You got the supply air coming in through a damper. So if this air handling unit has ever been off, when it's switching back on, the first thing that has to happen is this damper has to open, and only when it is open can the fans start to run. So there's that interlock for the supply and the extract. So the air comes in, we monitor the inlet temperature.
Hi, I'm John Bailey. I'm an engineer from Progressive Networks. We are at Hatfield University. Here at Hatfield University, we have installed network cabling, Cat6 XL network cabling. Cat6 is the category of cable, XL is the branding. We've installed approximately over 240 cables here to Prince Edward. Prince Edward is the main reception building, as well as it has classrooms, theatre rooms, etc. This is your server cabinet, essentially. This is what houses the patch panel end, and these are patch panels of the structured cabling. Now, as you can see, they're actually labelled room 110, which it says here, and we are actually in room 110. So room 110 is then corresponding to the lower ground, which are the lower ground cabling, and then the actual outlet number, which we'll show you later, which is 001, running concurrently up to 240. Also, we've installed a fibre optic backbone system. These fibre optics are 12 core, and this is going from room B110 to room 9-125, which is a intake room within the actual main university compound.
We're in the central core plant room on the 3rd floor. This is the air handling unit number 2 that provides supply and extract air to the central core of the building. The top fan is the extract fan, and the lower fan is the supply air fan. The extract air actually isn't ducted. There's louvers at low level, just the other side of these, the ductwork here. The extract air is then drawn through the atrium from the classrooms and everything via crosstalk attenuators and the linear grills. Here we have the inverter speed controller for the air handling unit, and also here is the gauge for the filters. The red indication here is when the filter is dirty and needs changing. So at the moment that's currently showing that the filter is in need of changing, which we will be doing shortly.
Once testing has been carried out, you must open this top valve. It's imperative this valve is opened. Failure to do so will render the system unoperational. And relock it. This system is now back to its operational state. So we've recorded the date, we've recorded the before pressure, we've recorded the after pressure, we've recorded the time taken for the gong to ring. The gong worked satisfactorily, stop valve is secured open, all other water supply valves are open, water storage tank full, and physically open the hatch and check the water level is full. We have just done the weekly test, so therefore water is seeping back into the tank. This will stop once water level has reached its full mark.
Your CCTV package consists of 2 screens. One screen is an immovable screen, and all it will do, it will circulate cameras through every camera you've got on the system. The second screen, you'll notice, is multi-screen unit, and that will display every camera you've got within the building upon pressing the multi-camera button. We will run through that in a second. First of all, you've got 11 cameras on the system, 4 of which are the last 4. This one is not powered at the moment because we haven't been supplied power to it. Once that's powered, that will come on and look very similar to the other 3 PTZ cameras you have here, all of which are controlled from said joystick. And with a very simple and easy motion, you are able to select the camera you need. You've got a choice, you can either use the buttons on the front of this unit here. This is your hard disk recorder, and the buttons 1 to 9 indicate the camera numbers on the front of the unit. Or indeed, you have a keyboard, of which you have a numbered keypad here, a joystick, and various buttons to operate the system.
I'm currently standing in the main electrical switch room that feeds the building. We're outside in a green enclosure, and it's where the incoming supply comes to the building. This here is the main switch for the building. There are 2 sub-main cables that run down into the ground. They're directly buried into the building and run up to the first floor main electrical switch panel. There are also a number of other electrical supplies in here which feed the cafe, referenced as supply 2. That's for future use for somebody else to fit out. The North Restaurant, the South Restaurant, which have their own individual isolating switches that have 2 sub-main cables that run through the system into our building. There is also a future supply for the Canal Trust, which they are going to install at a later date, that is going to run through the duct network that's installed running to the canal. So this enclosure should only be entered by competent trained operatives. It's not for general use, and it is a point of emergency isolation for the separate electrical supplies into the building. We are now standing in the first floor electrical switch room on the north side of the building. This is the incoming point of the main electrical supply from the external substation. Those cables enter here on the left of the panel. This is your main isolator switch for the whole building. This is what needs to be turned off if you want to isolate the whole building. We have a surge suppression unit to eliminate any electrical spikes, and we have all of the outgoing MCCB circuit breakers feeding loads within the building and demise. They are all separately metered, and they can be read here so you can see exactly what electrically is being used on each of the areas. To gain access into this panel, you need to be a competent trained person. There is a locked access. The door opens up and you have your individual circuit breakers feeding the various loads within the building. Everything is labelled up as to what it does, and they correspond with the switchgear out in the centre. There is a circuit diagram on the wall which tells you where everything is fed from and what cable size and all the electrical details.
So what we're going to do is, with the system in normal mode, which unfortunately it isn't at the moment, I'm going to put a controls activate key in the panel to enable the push buttons and turn that to the right. And for a weekly test, you utilise this shape key, insert to the middle of the break glass at the bottom until it clicks, and then pull the key out, generating a fire condition. And having got the fire condition to register, you then snap the break glass shut again by squeezing it top and bottom. And then on the panel we can mute the internal buzzer, silence the alarms, and ultimately we can then press the reset button, which should take us back to a system normal, and remove the key. And that is basically how you go about a weekly test. Adjacent to the fire alarm panel in the main entrance lobby, we have the disabled refuge alarm system. The disabled refuge alarm system enables people stranded in stairwells, on the escape stairwells on the first and second floors, to call somebody for assistance. The functionality of those call systems is only available during a fire condition, so the fire alarm panel itself has to be in a fire condition for the call stations on the stairwells to function. When you're not in a fire condition and you were to press a button on the stairwell unit, it would say system in standby, which is to allow the system not to be interfered with by students. So just to reiterate, the use of the disabled refuge call alarm system is only available during a fire condition. And if I just open the panel up, the 4 disabled refuge alarm points are associated with indicators 1 through to 4. The other buttons 5 through to 13 are associated with the disabled toilet alarms. Now the disabled toilet alarms, when indicated, will make a ringing noise at this location, but you can't speak to the disabled toilet positions. All you have to do is identify where the disabled toilet is, go to that disabled toilet and give the person the assistance they require. And to reset a call for the disabled